So I have 1/3 log base 5 of x squared y over 25. Excellent. 1/3 will stay outside and wait. Now I have log applied to a quotient. What do I do with that? Log base 5 of excellent. Okay, now I see I have a product. 1/3 is waiting outside patiently. Log base 5 of Now let's stop for a moment. Imagine that I put here just for this one equals y. 5 raised to which number is 25? No, 5 to the 5th is not 25. 2. So minus 2. When I can simplify, I will. One more time. Let's write it here on the side. Log base 5 of 25 is y, but I know that this is equivalent to, can anyone dictate? 5 raised to y equals 25. Y must be 2. Is that clear? Okay. So now I have one more rule to apply. I bring 2 down in front as a factor, and I will distribute 1/3 to all 3 terms now. So 2 over 3 log base 5 of x plus 1 over 3 log base 5 of y minus 2 over 3, and it's done. Any questions? Any questions? Yes. This one? So I distributed in here, and I had 2 over 3. I distributed in here, and I get 1/3. And then I distributed in here because I removed brackets. Better? Okay, very good. Anything else? Okay, I would like to go back and condense now, which is more important, because that's what we need for equations. Please choose from 41 through 70. 51. Where are you, 51? I see. And that's 1. Is it 1/2 in front? Natural log x. Very good. Plus natural log y. Good. We want to condense this, look here for a moment, to look like this. Log applied to one quantity, not a sum of 2 logs. We just want 1 log and everything in here, whatever that is. Good. What is the first step I have to apply? The power. I need to get rid of this. And I know that it's coming from the power of x. That's how it got there. It got there because this x had power 1/2, and then it was moved in front. Now I want to put it back. So this will be natural log. And what does x to power 1/2 mean? The square root of x. X to 1/2 is the square root of x, and x squared is something else. So then plus natural log y. Now I have only one property left. This is the sum of 2 logs. Where does the sum of 2 logs come from? From natural log of? Exactly. Since I cannot put anything behind the square root, I'm going to write y the square root of x. Very good. I would like to look at 69. Log x plus log x squared minus 1 minus log 7 and minus log x plus 1. And want to draw your attention to something before we continue. See, this 2 came from the numerator. The sign in front is positive. See, this 1 came from the denominator. What is the sign in front? Good. Let's come back here. See, these 2 come from the numerator. What is the sign in front? This one, the 25, came from the denominator. What is the sign in front? Good. So when you look at these 4 logs, 2 of them have positive, 2 of them have negative. Where will these quantities, where will they come from? Or where are they coming from? The numerator. Where will these quantities come from? So you know how to condense this in one step. Please tell me what to write. Can anyone give us the numerator? Can anyone give us the denominator? That's it. There is one more step, however, because x squared minus 1 is factorable. So what would you tell me to write? So how do I factor x squared minus 1? Very good. And one factor goes away. That factor is? So the simplified form is log x minus 1 over 7. And we condensed an expression that had 4 logs into an expression with 1 log. Good. That's all I want to hear. When I hear that, I feel like I did my job. Very good. Now I want to apply these, hopefully, but not, I don't think we can apply them today, all these rules. Exponential equations. Some are extremely easy, some are extremely cumbersome. Not difficult. Here's our first equation. Very easy. Two numbers are equal and they have the same base. How much is x? Good. Here's the next level now. 3 raised to 2x plus 1 equals 27. This one is problem 6 on 489. Now, it's still easy, but more difficult than the first one, because I have to show, I'm always trying to see if I can write both sides with the same base. The left-hand side is 3 raised to 2x plus 1. Is there any way of writing 27 with base of 3? How? Good. So now I'm back to the original problem. Two numbers are equal and they have the same base. What has to happen? So what do I have to write? Just dictate and I'll write it. Exactly. So 2x plus 1 equals 3. Please do not say that we are simplifying bases. That's not what we are doing. So then this is 2x equals 2, so x equals 1. Okay, problem 19. 8 raised to x plus 3 equals 16 raised to x minus 1. Now this is slightly more difficult. Still both sides can be presented with the same base. What base is that? 2 raised to which power? Very good. Everything in parentheses raised to x plus 3. What about the right-hand side? Very good. In parentheses, raised to. I'm not there yet to make a conclusion, to draw a conclusion. Copy the base. What happens to the exponents? Correct. We multiply them. What do I have now? 3x plus 9. Copy the base. What do we have on the other side? Now I'm back to the original problem. Two numbers are equal and they have the same base. What has to happen? Indeed, 3x plus 9 must equal 4x minus 4. This is linear. I move terms around. I can get negative x equals negative 13, so x equals 13. I moved 4x to the other side. 3x minus 4x is negative x, and I move positive 9, but it's negative. When I move it to the other side, I get negative 13, so x equals 13. Any questions? Now the next problem, I'll see you on Monday. Now he told me that he was going to leave early. Now here is the deal. Problem 25. E to the x equals 5.7. Now, no matter what I do, I will never be able to present e and 5.7 with the same base. That's not possible. There is still a way of solving the equation. Remember what we did with this equation, the square root of x equals 2. What did we do to both sides to solve this equation? Right, we applied the inverse function. The same thing here. I want to apply a function that will bring this power down in front. Which function will do that if I apply it to both sides? Natural log. So I apply natural log to this side and natural log to this side. Therefore, natural log e to the x equals natural log 5.7. I bring the power in front. I'm allowed to do that. It's natural log. Now I'm asking myself, what is natural log e? This is an important property. That's why I want to talk about it. Natural log e, let's say I don't know. I'm going to call it y. But I know that the most important concept in this chapter is the fact that any log equation can be written as an exponential one, and any exponential, vice versa. So, please tell me, what is the base here? I don't see any base. Careful. Base 10 is in log. There is no base 1. There is no base 0. There is no base 1. There is no negative base. E. E to y equals e. E to y equals e. Now how much is y? 1. So then this is 1. So how much is x? Natural log 5.7, which you can approximate if you want.
Can you say that one more time?
Yes. I am given the equation e to the x equals 5.7. I know that only one mechanism, I don't know how to solve this, but I know that there is a mechanism that I apply to both sides that allows me to bring x in front. And also I'm applying, like here, I'm applying the inverse function. So I apply natural log to this. So if two numbers are equal, their logs will be equal. So like here, if two numbers are equal and they have the same base, their exponents have to be the same. If two numbers are equal, their logs will be the same. So I apply natural log to both sides, and then I said, okay, I'm allowed to bring x in front, so I have x natural log e equals this. Now the question is, how much is this? I don't know. But I know that natural log e equals y means e raised to y equals e. So we don't write, instead of writing log e, which would have been easier, we write natural log, which is assumes that the base is e. Therefore, e raised to y equals e. E raised to y equals e. And now I'll say, okay, two numbers are equal and they have the same base. So therefore, y must be 1. So this number is 1. Therefore, x times 1 is x equals natural log 5.7. Any questions? Okay, it's 6:13. I have time for one more problem. Let's say, I don't want to do that, it's too long. Number 41 is long. Let's do 37, last one for today. I did not finish, so the test will not be a week from today. It will be the following Monday. I need a time for logarithmic equations and word problems, which we will be able to finish on Monday, so that I can review everything on Wednesday. So that my brain cannot think right now. So is the 14th? Yes, the 14th is the following, not Monday, but next Monday. Correct. Okay, 37. So I can let you go. 7 raised to x plus 2 equals 410. Can I present 7 and 410 with the same base? No, of course not. So then what mechanism will you apply to both sides so you can free up that power? Natural log or LOG, doesn't matter. So log. Here I applied natural log because the base was E. But here does not matter, 7 and 410. So then I have log of 7 raised to x plus 2 equals log of 410. What will you tell me to do next? But in parentheses, this is the key. X plus 2 in parentheses, log 7 equals log 410. And yes, I will divide both sides by this number. Let's write it like this time. This goes away. And then you have x plus 2 equals log 410 over log 7. And what will be the very last step towards solving for x? No, I cannot divide. Yes, I subtract 2 from both sides. Log 410 over log 7. Thank you. Have a good weekend. If you have any questions, please stay. If you have your homework, please turn it in.